Ultimately, we can do the two operations, either to read or write operations. Okay, with the programmer, if you want to write the something program that should be stored where in the memory itself. Okay, in the memory. Programs are written with the number of instructions. Okay, these instructions to be fetched, we are written. Okay, to be write, and even we need to write the read from the memory. Okay, this is to be done. Okay, if the processor wants to the memory, processor wants to. This is what the processor. This the processor wants to the read. Okay, so the program, then it has to be what the read the program. Read the program. This program will be read as the one by one instruction. It's the one by one instruction. Okay, if the program is written, okay, read from the memory. Okay, then with the help of what the read operations, or we can say what the fetch operations. If you want to write back, if the result is stored back to the memory, if the result is stored back to the memory, result is stored back to the memory, then this is to be done with the what the write operations. Then you can also store. You can say what the store operations. Okay, there are two operations related to memory operations with the help of the memory. If the processor wants to read any program from this one, okay, then the program has to read it to the processor only with the help of the one by one instructions. This is to be done with the instruction read operations or with the help of the fetch. You can say it's what the fetch. Okay, after the processing of that particular instruction or particular program, the result is stored back where in the memory itself. This is to be done with what the store operations, or you can say it's what the write operations. You can say it's what the write operation. These are the two operations to be done with the help of the interact with the memory with the processor itself. Okay, read and write operations. Okay, usually the read operation, suppose I am using the load instruction, and also for the write operations I can use the store instruction. Load instructions is used only to fetch the data or program related to this one instruction from the memory to what the processor. From the memory to the processor. This is what is called the load. If any operand, if any data present in the memory or any instruction present in the memory, that is to be read with the help of the what the instruction load operation. Similarly, if you want to after processing of that instruction, the result is stored back to where the memory. Okay, this will call the write operations. This is done. This is the operation, the write operation to be done with the help of only what with the help of the instruction called the store instruction. There are two instructions in the related to memory operations for the read and write. For the read operation purpose, I will be using what the load instructions, and also write operation purpose, I will be using what the store instruction. This is what the memory related operations should be write. Okay. If the memory operations, if you are processing that particular program, if you are processing that particular program, that is to be read only one by one instruction. One by one instruction. That we call for the fetch operations. Okay. Data transfer for the memory locations and processes. Okay. After fetching that particular operation, that is to be stored where this results where the control unit. The control unit will decide what type of operation it is to be going to done. This is to be done controlled by whom? Control unit. Then that particular unit, okay, that control unit sends the information to the arithmetical logical operation to perform the operations related to it. Okay, the control signal will sends to where the A unit that will be perform what the arithmetical logical operations. What type of arithmetical logical operations it has to be done? That is to be decided by whom? Control unit. And after performing the arithmetical logical operations, then the programs will be sequencing. Okay, program will be sequencing once again. That is to be next instruction to be fetched, next instructions to be fetched. Like this, it will be performing, and also next instruction to be performing. That's nothing but the program control will be fetching the next instruction. Okay, then the next instruction is to be performed. After full execution of the program or full execution use of that particular data, that is to be stored back to the result, to the what the user. This is to be done with the help of what the IO devices. What's that? We can say it's for the IO transfer. We can say it's for the IO transfer. Okay. There are 4 main steps here. First, it has to be stretched one by one instruction. If you want any, if the microprocessor has to wants to read or fetch that, but execute that particular instruction program, then the processor has to read one by one instruction from the memory location. Okay, that we call the fetch operation. After that read operation, then the control will decides what type of operation has to be performed by the AE. But by whom it will decide by who? Program controller or something controller. This controller will service the signals to where arithmetic logical unit. It will perform the related operation. Arithmetic operations are logical operations. After performing that result, that is to be stored where the output devices that is to be decided. This operation we call as the IO transfer operations. Then I hope you are following this one. These are the main steps. First, read operations and load instruction ಕೊಡ್ತೀವಿ. Write operations, store instruction ಮಾಡ್ತೀವಿ. ಯಾವ ತರ ಒಂದು ಲೋಡ್ ಆದ್ಮೇಲೆ ಸ್ಟೋರ್ ಬ್ಯಾಕ್ ಇದು ಲೋಡ್ ಆಪರೇಷನ್ಸ್ ಒನ್ ಬೈ ಒನ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಲೋಡ್ ಮಾಡೋದಕ್ಕೆ ಫೆಚ್ ಆಪರೇಷನ್ ಐತಿ. After that portion of that particular instructional program, then it will be sent to where the IO devices. Then we can switch for the store operations. Okay, store operation. Like this, we have the 2 type operations. One is the store operation. One is the fetch operation. Another one is the store. One is what the read operation. Another one is what the write operations. Okay. There are 2 operations related to memory with the interaction between the memory and the processor. I hope you all follow. Just to copy this one. Okay. Next. Register transfer operation. Transfer of the transfer of the information from the locations to the memory. Okay, locations to the memory locations to what the registers. Okay, that's to be done. Okay, usually the locations to possible locations will be what the possible locations are on the processor registers. Processor registers. Another one is what the memory. Processor registers, another is the memory locations are IO system, or you can say for the IO registers also. Okay, register transfer operations usually done the data to be transferred between the processor register to memory or IO locations also. IO locations. Okay, IO locations that we call for the register transfer rotation. 2 types of register. Okay, then what is that? Processor register. Another one is the memory locations of IO register. Okay, what is the processor registers? Around the 7 registers as you already seen this one. Okay, which are those? The stack of registers are there. In the program, in the architecture of the our system we have seen. Okay, in the computer. Okay, there we have seen the registers to R0 to Rn minus of 1. Okay, this number of stack of registers present in the system. That's the process. We can say for the processor registers. Memory locations can also be used for the storing purpose of the data. Those locations also can sometimes called as the registers. What type of registers? Memory registers. M location of registers are there. We will particularly, okay, that we will be discussing. Here the we can say for the memory locations, for example memory locations. Okay, for example memory locations, those to be given as the name as the location where place B, or also we can say for the some other like locations also B are also. Register registers are there. What are those registers? Those registers are which of those are not like this. Are not like this. We can give a name file also one. And also IO registers are there. IO registers. IO registers. Which of those IO registers? Data in and data out. Okay, data out. Okay, registers notations. Okay, usually the register will have the some notations. Okay, if I use the particular registers with the process, this can will have the some notations as the process register would be the R0, R5 something. This to be named. Okay, name notations means we give the some names for that particular register. If you use the process registers related to what the person, then I should can use what the R1, R2 like this which can use. If I use the memory locations as registers, memory location, this location, if I write this particular LOC, this particular memory location store what the some data that is to be considered what the this is also sometimes called the register only. This particular location will store what the particular data. So that storing of any data we can refer to what the register. Or this particular memory location is also referred to what the register. This is the register related to what the memory. This particular memory location is itself used as what the register for the storage of the data. Even the place also, you can give the name as the place, you can give the name as the D, something, whatever the names, you can give the names. Okay, these are because the memory locations. Okay, memory locations. These memory locations can also be named as what the registers. Registers. Okay. If I use the IO registers, if I use the any IO devices, it will have the its own registers for the storage. These are the temporary registers. Okay. These are the what the temporary. Data in and data out are the data in is related to input device. Data out is related to what the output device. If I use the data in as any instruction with this particular data in word, this is the related to what the input device register. Input device register. If I use the data out in output device instruction, this is what the register only. This is what the register would use to store the data which is present in what the output. This is what the output. Okay. The data is used. This data is one of the registers related to what the input device. Data out is the one of the registers related to what the output device. You should remember. These are the some notations we will be using the register transfer notation. You can say for the if you are okay. If I use the for example add instruction. This is what the add instruction is. What the instruction.
Yes, sir.
To what the addition operation. This I use location of R1. Okay. This is what the memory location. This is the instruction which is having the two address locations. Okay, two address. First address, second address. This is the source. This is what the destination. Yes, no.
Yes.
This is what the source. This is the destination. If I use, okay, this R0 content is added to the contents of the memory location. The memory location only, location will have some data. This data, if it is 22, this location consists of the 22 value, and also R0 is having the 23. Then the definitive stored value 45. Then this 45 value is stored back to where in the register R0 itself. How to write it? Okay, R0 plus of location stored back to where in the register in the back to where in the register R0 itself. Register R0. Contents of R0 is added to the contents of the location, particular location address. There it is having some data. This data and the contents of this data, these two are added together. Then the result is stored back to where in the register R0. It means here that this is the source, this is the destination. This is what the operand. You can say what the this is what the output, this is what the source, this is what the destination. This is the source operand, this is the source operand. This is the destination operand. This is the source operand, this is the destination. It means what I am saying here, going to say here, location. This LOC is having some addresses. This particular address location having some particular data. For example, location address is having the 22 as the data and RRT is contains is storing the 23 as, then definitely what is the value of this one is total value is the 45. Then this is the add instruction will be having the particular operation which is needed. It means here register transfer rotations. Register transfer rotation have the two types. One is the processor registers, another is the memory locations or IO registers. There are three are there. One is the processor registers, memory location address registers, IO registers. For example, memory location is LOC, place, board. These are what the registers only, but related to what the memory. Related to what the memory. This is the processor register R1, R2, R3. Like these are registers related to what the processor. And also IO registers, a data in register. Data in is also one of the registers related to input device. Data out is the one of the registers related to what the output device. Okay, these are the IO registers. What you can say. For example, if I consider the add instruction having the location and the RR. Okay, contents of location RR is added together in the register RR and stored back to where in the register RR itself. Okay, this is we can say is for the upload. This can be say as the source upload. This is for the destination upload. Location of contents of location are added to the contents of the register RR. Contents of register RR and contents of register location is added to the together and stored back to result stored back. After result, okay, this is what the 22. This is what the 22. This is what the 23. Stored back to where result in the 45 where in the register RR itself, because register RR is what the destination registers. Contents of these two are added together and result is stored back to where in the overreturn actually. Contents of overreturn register RR itself. We can say it's what the register transfer rotations. Next is what the assembly language rotations. Next is what the assembly language rotations. Usually the memory, if any locations, if any memory locations having the are used in the instruction as the registers, those to be always filled with the square brackets. Square brackets. I usually have the story of the square bracket here. Okay. Usually the memory locations of the particular memory locations to be used as the register, those to be written between the two square brackets. This is called the particular memory locations having the data. This data is used in our instruction. We can say this is what the memory registers notations. With the square brackets should have. Don't write it. If I yes, you can see here. Just to see here. This is what the location I shown here. Okay. Okay, this I shown. But while writing the operations, you should have to use. I use here what the square brackets. I hope you all understand this. That's the earlier I was using the directly, but while after doing operations, I use the square brackets here because the contents of that particular location and the addresses, that addresses will hold for the some value, some operand. That value is added to the contents of the register R0 and stored back to in the register R0 itself. We can say for the memory address, memory registers. These are the memory location and processor registers and IO registers like this. Next is what the subtract. You can say for the subtract and R3. This is for the three address locations. Okay. If I use the contents of R1 and R2 are subtracted, I am stored where in the destination register. This is what the source one, this is the source one, this is what the destination. This is what the upload. This is what the upload. This is the upload. This is source register. This is the second source register. This is what the destination register. Contents of R1 and R2 are subtracted and result is stored where in the register R3. You add to the minus for the result is stored from R3. One way put it the destination register R3. Okay, this is what the processor registers. Okay, related to processor registers. Okay. Okay. Next to consider this one. You can use it in squares also. But not the circle right. But it is better to use the square always. Okay, next. Assembly language notations. And consider now assembly language notations. assembly language notations. Assembly language notations. Okay, some operations are there. Okay, some operations. Okay, if I use any operations to be done a plus b, a plus b. This is what this is stored back in the register C. These are the what the source one,
source to destination.
I added to model the destination. This is the assembly language notations. Okay, assembly language is nothing but if any instructions which will be used in the writing of the programs, those we call as the assembly language instructions. Those assembly language instructions to be used as the some notations. Then I will be using some notations. How to write it? Okay, there are three types are there. One is for the one address instructions. Second one is the what the two address instruction. Third one is the three address instruction. Fourth one is zero address instructions. We'll consider the one by one. We'll see that one. Okay, there are according to the address references, we have the three types of instruction types. Okay, one is for according to the address types. Okay, according to the address references, there are three types of instruction. One is called the three address instructions. Second one is called the two address instructions. Third one is called the one address instructions.
Zero address instructions.
We have the zero address instructions also. But according to what the according to address reference, we have the three type of address instructions. One is called the three address instructions.
Two address instructions.
Yes, second one is the two address instruction.
One address instruction.
Third one is the one address instruction. One address instruction. We'll consider the one by one. Okay, first one. Okay, first one we'll consider the three address instructions. First one is what?
Three address instructions.
What are the three address instructions? Okay, the general format of the three address instructions is what the operation. General format. Okay, general format for three address instructions. For three address instructions would be what is the first one is the operation. Okay, this is the source one. This is what the source two. This is what the destination. Okay, you should remember always. Okay, destination comes always to the rightmost side. Okay, for example, if I consider, okay, this is what the general format of the instruction which can be the three address instruction. Three addresses. This is the operation code. Okay, any of you have the three addresses. Say 1, 2, 3 here. Okay. First one consider the source one, and whatever the remaining is the destination. Okay. For example, add A, comma B, comma C. Add A, comma B, comma C. How can we write it? Okay, this is the what the A plus B. A plus B. Source one. This is the first source. This is the second source. Okay, these are the sources. These are the destination. These are the stored in the
Destination.
Where the destination. What we are doing here, addition operation. For this purpose, I use the plus operator. Okay, then the addition operation result is stored in the register. Okay, the C. This is what the three address instruction. If I go with the two address instructions, okay, two address instruction. Two address instruction. This is also we have the general format for this three address two address instruction. We have the as the operation. Of course, what is the operation, what type of operation we are doing, that's to be debated. This is what the next is what the
Source 1.
source, then the next is what the
Destination.
destination. What are the thing, okay? This is what the general formula. For example, consider the example as the add AB. We come up with the other source and destination. This is the source and destination. This is what the destination. Contents of A and B are added together. Result is stored back together in the destination distance. Okay. Let me see here. Okay. Let me write A contents of A. Square bracket is stored in the contents of that particular resistance. Okay. And B are added together. A and B add together. Result is stored back together in the destination of the
ಬಿ ಮತ್ತು ಬಿ ಪ್ಲಸ್ ಮಾಡಿದ್ದು ಬಿ ಪ್ಲಸ್ನು ಮಾಡಿದ್ದಿಲ್ಲ ಸರ್
A plus B ಮಾಡಿಲ್ಲ. A plus B ಯಾಕಂದ್ರೆ ಎರಡೇ
ಹ್ಞೂ
source ಮತ್ತು destination ಎರಡು ಆಡ್ ಮಾಡ್ತೀವಿ. result is stored back where in the destination register. ಇದು source ಇದು destination register ಏನಲ್ಲ source ಒಳಗೆ ಆಡ್ ಮಾಡ್ತೀವಿ. ಮತ್ತೆ result is stored A ಮತ್ತು B ಆಡ್ ಮಾಡ್ತೀವಿ. that the result of the contents of B is overwritten. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಇದು 22 ಅಂತ ಇದು 23 ಅಂತ ಈ 22 plus 23 ಎಷ್ಟು
45
45 ಬಟ್ B ವ್ಯಾಲ್ಯೂ ಏನು ಫಸ್ಟ್
22
22 ಅದು ವ್ಯಾಲ್ಯೂ ಏನು overwritten ಅದು ವ್ಯಾಲ್ಯೂ ಏನು overwritten contents of this A register is added to the contents of register B and then the result is stored back to where the B register itself because B register is now overwrite ಆಗುತ್ತೆ ಗೊತ್ತಾಯ್ತು ನೆಕ್ಸ್ಟ್ come to the
one add
instructions. What are the instructions? What are the instructions? General formula for the one instructions for the operation. Next is for the source. Next is for the source itself. Source one. Next is for the source itself. Source one. Okay, this is for the general formula for the one address instruction. What is the one address instruction? For example, load. Everyone will load A. Load A. Add B. And store C. Contents of A register is loaded. Okay. ಆಮೇಲೆ add B. B ಜೊತೆ add ಮಾಡಬೇಕು. ಹೇಗೆ ಬರೀತೀವಿ?
stores
ಏನು ಬರೀತೀವಿ? A plus
B
B ಬರೀತೀವಿ. Then the store result is stored in the C. ಇದು load A ವ್ಯಾಲ್ಯೂ 1 ಆಯ್ತಾ? B ವ್ಯಾಲ್ಯೂ 1 ಆಯ್ತು.
Yes.
ಈ A ಮತ್ತು B ಎರಡು ಕೂಡಿ ಏನು ಮಾಡೋದು ಇಲ್ಲಿ? add ಆಗ್ತದೆ. ಏನು ಕೊಟ್ಟಿರೋದ್ರೆ ಇಲ್ಲಿ ತಗೋಬೇಕಂತ ಅಕ್ಯುಮುಲೇಟರ್ ರಿಜಿಸ್ಟರ್ ಎ ಅಂದ್ರೆ ಅಕ್ಯುಮುಲೇಟರ್ ರಿಜಿಸ್ಟರ್ ಏನೇನು ತಗೋಬೇಕು ಬಿ ಏನು ಕೊಟ್ಟಿರೋದ್ರೆ ಪ್ರೀವಿಯಸ್ ರಿಜಿಸ್ಟರ್ ಏನು ವ್ಯಾಲ್ಯೂ ಅದು ತಗೋಬೇಕು ಎ ಬಿ ಇಸ್ ಆಡೆಡ್ ಟು ದ ಪ್ರೀವಿಯಸ್ ರಿಜಿಸ್ಟರ್ ಎ ಪ್ಲಸ್ ಬಿ ಅಂದ್ರೆ ರಿಸಲ್ಟ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ರಿಜಿಸ್ಟರ್ ಸಿ ಎ ಪ್ಲಸ್ ಬಿ ರಿಸಲ್ಟ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ರಿಜಿಸ್ಟರ್ ಸಿ ದಿಸ್ ಇಸ್ ವಾಟ್ ದ one address instruction. Next is what the zero address instruction.
yes sir
Okay, zero address instruction. Zero address instruction. Zero address instruction have the okay, push. General component is what the
push
operation itself. Okay, the operation itself, operation of output itself. Okay, and for example, push might be pop or the two instructions which are called the zero address instructions. This will be called the zero address instructions. Zero address instructions. Okay.
yes sir
Okay, just to copy this one. What is that?